We've just worked number one. If you guys are watching at home, we've got 5 little suggestions or strategies up there for solving equations that involve logarithms. Okay. And so you can pause the video and jot these 5 down. My guys here in class, you guys have already had a chance to write them down. Let's look at example 2, where maybe we've got a little bit of pre-work to do. Nicholas, what do you want to do first? Okay, what would you do first? So we get 9 on the right. We got 8 to the 2x minus 3. Now, at this point, okay, like last problem, this previous problem, I forget who suggested, Stephen maybe, had said do the can you see it. At this point, Nicholas, what would you like to do to both sides? I think that's a lovely idea. Log base 8 of the left, log base 8 of the right. Those cancel out per our inverse property of logarithms. And we're left with 2x minus 3. Now, that indeed is half the battle. Okay, old G.I. Joe style. So Alfredo is going to tell us what to do next. To get x by itself. Turn around. Quit distracting. All right, I want to take care of the 3 first. Before I divide everything by 2, I'm going to kick the 3 over. That's my personal preference here. So we're going to do 3 plus log base 8 of 9, and then we'll divide it by 2. Now, what is log base 8 of 9 in its essence? It is, no. In its essence, I don't want specificity. Generally speaking, it is a
irrational number.
Take away the adjective. Take away the
a number.
A number. Log base 8 of 9 is just a number. Now, you guys were saying, oh, it's an exponent. Yeah, that's true. I mean, a logarithm is an exponent. We've got that down pat. But in its essence here, this is just a number. It doesn't look like a number. If you went to a second grader and was like, hey, I've got a new number. It's called log base 8 of 9. They're going to think you're a crazy person. But it is a number. Okay? And so treat it like a number. So when I'm talking to Alfredo, he wants to get those numbers together. He's going to add 3 to both sides because those are both numbers. And then he's going to divide by 2 because those are both numbers. Right now, I could enter that in on my calculator if I'm savvy. And I know some of you guys are charging your calculators at the moment, so we'll do a little fraction action. 3 plus, and then math, alpha math, log base 8 of 9, and then 2. And we hit enter. We get about 2.028. About 2.028. All right. Now, is what? Listen, y'all have got 6.1, 6.2, 6.3, and 6.4. Those are our 4 sections on logarithms. Come Monday, they better all 4 be done. I want them all 4 done. Now, truth be told, like 6.1 was due, what, over a week ago? And 6.2 was due a couple of days ago. And 6.3, I think I've got set due for Friday, and it's 6.4 due Monday. But like Monday's deadline. I mean, I'm talking dead in the dirt deadline. You ain't got it done, you ain't getting credit. Monday, 3 p.m. Get it done. Also due Monday at 3 p.m. is a little take-home quiz. Okay, it's your lab quiz. It's not a group quiz, so you're not allowed to work with other people. It's a on your own kind of quiz. You can use a calculator. You can use pencil and paper. You can't use a computer. You can't use any notes. Can't your work. Have to show your work. Would you like this now, or is this going to distract you during class?
It's going to distract. It's very much distracting.
All right. Make sure we get it before we leave.
How many questions do you do?
7 questions, 2 points a pop. You get 1 free point, so it's out of 15.
All right.
Mikey? Yes, sir.
All right.
What's today? Wednesday. Plenty of time. Plenty of time. Now, you not done that yet?
No.
When did I have that set due?
I didn't know you were still down there.
Hey, real quick, we've made use thus far of 2 of our strategies, the can you see it, and then the take the log of both sides to match the base. Technically, those are the same thing. Let me tell you about a nice lady named Miss Walker. Miss Walker teaches some upper level math classes. You will likely have one of her classes in the next couple of years. And she is a big fan of this fifth strategy of taking the natural log, dealing with things in terms of natural logs. Okay. And so let's look at, oh, that one's not a good example. Let's look at this example 2 with, or actually, I wonder if I could go through homework example. No, I don't have any of those. We'll just repeat the same example. Let's look at this one through a different lens and see if we can get the same answer that way. Okay, we got pen. There we go. So I've got 8 to the 2x minus 3 equals 9. Well, everybody's comfy at that point. But instead of doing the can you see it or take the log base 8 of both sides, I'm going to take the natural log of both sides. This is an alternate technique, okay, that's very much in vogue for a calculus class. Now, at this point, Henry, we need to use log law number 3. What does log law number 3 tell me to do with that exponent? There we go. And so now it's 2x minus 3 as a group. That's a coefficient of natural log of 8. Class, what is natural log of 8?
A number.
A number. And so I could divide both sides by natural log of 8. Consequently, using the change of base formula, what is natural log of 9 over natural log of 8, but natural log of 8, a base 8 of 9. You know what I'm saying? So we're really doing the same thing. It's just with maybe of a little bit of a different slant to it. Okay, Aiden, you with me? All right. And so at that point, we would add 3, and we would divide by 2 or multiply by a half. So I've got x equals 1/2 times natural log of 9 over natural log of 8 plus 3 in parentheses. And we should end up getting, that same value. So whatever floats your boat, if you're a can you see it guy, if you're a take the log of both sides guy, or if you're a take the natural log of both sides guy, those strategies that are up here at the top will help you on the take-home test, take-home quiz, whatever, little 15-pointer that you guys are going to get. So if you get an equation that's got some variables in the exponents or logarithms, that's what you're going to make use of. This fourth strategy of get the base to be the same, we're about to see it in example 3. Okay, Freddie, go back to the what? Take natural log of both sides, then apply log law number 3. Waiting for BJ. You good? All right, and then in green there, Danae Green. Franklin, you good? Aria.
On example 3, if you were to take log base 10 of both sides, would that
Totally work.
the 100?
Totally work. Because 100 is 10 squared, and you could just dump the 2 up there with the already pre-existing exponent, and then you'd have log, cancel, cancel. We could do it that way. I wouldn't recommend it, but like if in Mario's question, he's like, let me take the common log of the left and the common log of the right. All right, now, but 100 is the same thing as 10 squared. And when you know that when you take the exponent and then you have another exponent, it's just like multiplying those 2 exponents. So now these 2 would cancel out, right? Because the implied base for common log is 10, and those 2 would cancel out, giving you x minus 3 equals 6x plus 22. And that's a linear equation at this point. All right. So totally fine doing it that way. I probably wouldn't, but whatever floats your boat. Freddie, here's what I'd like for you, my man. I want you to try and make the base the same. Let's do a little, treat this like an algebra 1 question. What's 100 the same thing as? Good. And so now that the base is the same, I can equate the whats. Don't say the word log. This is a whole class question. Once the base is the same, we can equate the exponents. We can say, hey, look, this exponent and this exponent are now equal. And there we got that same equation like Mario had in his way. And from there, can I leave you guys to solve it?
Yes.
That's a linear equation, easy money. Maybe -5, something like that. By the way, what should you, this is going to be weird. You guys at home don't get to see this. What should you always look for when you're working these types of problems, Christian? An extraneous solution. Okay. The extra anus. Like you will encounter extraneous solutions with logarithms because you're not allowed to take the log of a negative number. You're not allowed to take the log of 0, right? You're not allowed to have a negative base. Like there's all these restrictions that come along with logarithms. Okay. And so just be careful. So if we found -5, maybe in some problem, -5 is an extraneous solution. Just be on the lookout for that. You'll see that in some of the homework questions. Here's our next example. Mitch, am I going too fast?
No, you're fine.
All right. So in this example, this harkens back to Monday's class. Mitchell, you with me, Mr. Gilmore? What log law do you want to employ, Gilmore, on the left side? Go the other direction. Instead of expanding, once you condense. Good. Now, what type of expression does that produce? Very nice. And a quadratic is going to have how many solutions, Phil? It's going to have 2. Let's see. We call this the common logarithm. So can you, Sebastian, either do the can you see it or the inverse property of logs? Tell me what my next equation is going to be, given that this right here is an implied 10. All right, so I might do the can you see it approach. 10 to the power of 2 equals 5x times x minus 1. And there's your quadratic equation. And everybody should feel comfy solving a quadratic equation. Franklin.
How do you know when the log is 10 and not Euler's number?
Good question. That's not a bad question at all. If you saw Ln, that's where it's Euler's number. If you see LOG, that's where it's an implied base of 10. That's essential understanding. So we've got to make sure nobody in here needs to leave confused about that. So Ln is when you've got a base of Euler's number. LOG is when you got an understood base of 10. Other than that, they're going to tell you what the base is. Okay. Now at this point, which 2 answers do I get? Let's see if I can employ ye old calculator to solve my quadratic for me. Okay. So why don't I go, I'll be fancy. I'll use my polynomial simultaneous equation solver. Let's see here. Let's go next. All right, what's my leading coefficient going to be? 5 and then minus 5x. So let's change that to minus 5x. 5x squared minus 5x. And then what? Minus 100. And then we'll hit solve and we get -4 and 5. Oh, that's nifty. How would we solve it by hand? Oh, I'm so glad you asked that. We'd kick the 100 over. We'd set it equal to 0. We would distribute the 5x.
With the -5.
We'll figure it out in a sec. 5x squared minus 5x minus 100. Now, all of that's divisible by 5. So take out a 5 as a GCF. And then we wind up, this one factors. See, I'm old school. I like the factoring technique. So this will be x minus 5x plus 4. So we know our solutions are going to be 5, -4. But, Christian, well, look out for the extraneous solution. You said that a second ago. So if I were to take -4, for instance, and plug that in, now I'm asked to calculate the log of -20. Michael Davis, you got your calculator out. What's log of -20? Michael Davis is who I called on. Michael, what'd you get? I think you must have entered it in incorrectly. Log of -20. You know what I'm going to get? Error! Dun, dun, dun. Because you can't take the log of a negative number. All right? Error. That tells me that -4 is an extraneous solution. So I should definitely throw it out. Okay? Now, 5, on the other hand, looks great. So log of 25 plus log of 4, does that equal 2? I want to check that out. Does that equal 2? Okay, so calculator away. Let's do
Log of 29.
Let's do log. Oh, it'd be log of 100, my friend. Log of 100 because you multiply, and we wind up getting 2. Now, how did I know 100? Very good. So I don't have a clue, Michael. I saw you with the calculator. I was like, oh, he'll punch that in. Lickety split. That's okay. Hey, you might have used a minus sign instead of a negative. Maybe something like that. Okay. Anyway, the reason
giving you an error.
the reason that I knew this was log of 100 is because of log law number 1. When you're adding the logs and the base is the same, you multiply the arguments. 25 times 4 is 100. And then, as Nash said, common log, whose base is 10, of a 10 squared, cancel out, and you're left with that 2. All right.
Do you ever answer that?
I hadn't had a chance to. Speaking of questions, what makes this one, Freddie, pick your head up. What makes this one kind of weird? What do you think, Eli?
Oh.
Yeah, that base is a fraction. Blech, we don't.
A lot of log.
Yeah, so it is going to apply some log laws. Andrew, what is that first term which log law is that first term gonna use? Not necessarily, maybe the first, those two, but I'm just saying, like, before I can apply log law number 2, the quotient one, what do I have to do on this first term right here? Let's take the 3 and move it up top. We're going to use log law number 3. That coefficient is going to become an exponent. And so now I can condense, my base is 2/3, and I got x cubed over 27. Right here.
Oh, you just, okay, never mind.
So we had 2 logs on the left, and we squished them together using log law number 2. We condensed them together because the base was the same. Now, here's something I'm not sure if you have seen this or not, but if you've got the same log on the left and the same log on the right, you can equate their arguments.
Oh.
Right? Now, the reason of why can I do that? Well, imagine if I said, let's make 2/3 the base on the left and on the right, and those cancel out, those cancel out. Or you could just simply say, hey, the same log on the left, the same log on the right, their arguments will equal. Welcome to the party, Kenneth. X cubed over 27 now equals 8. Friends, what kind of equation is that? It is a cubic. How many solutions does a cubic equation have? It has 3. What would you do to get the solution? Get x by itself. Now, here's a tricky little thing to consider. Do I actually have to multiply? So before I multiply, I definitely would take the cube root, because I notice what? What about 8 and 27? They're both cubes. So I wind up with x equals 6. But wait, Coach Morgan, there's 3 answers. What are the other 2?
One the double. Double.
Imaginary, complex numbers. So I'm not even concerned with that. Can I take the log base 2/3 of 6? Am I allowed to do that? Certainly I am. Now, let's say, and this is not necessarily the point of this class, but like, let's say that I just had a big old fat brain fart and I forgot how to solve equations. Okay, I technically could go to my y equals screen. I could type in this left side. Okay, so math, alpha, math. The base is going to be 2/3. What's the argument? X minus math, alpha, math. Base is going to be 2/3. 27. And then I could graph on this other side, math, alpha, math, basis of fraction, 2/3, 8. And I could see where they what? See where they intersect each other. All right. And if I hit second trace, enter, oops, sorry. Second trace 5, enter. What did I do? Dadgummit, hold on. Second quick graph. There it is. Second trace 5, enter. Maybe my number lock is off.
I gotta take it. I'm gonna turn one of the something up here. Turn something on there.
There we go. X equals 6. I think my keyboard is messed up. So if worse came to worse, like you didn't have to know how to solve that equation, you could technically find the answer. That's a hack. Again, that's not ideal, but if you're in a pinch, what else? Okay. Everybody got that? You try one. Do a little consolidating. Here you get a rational equation.
Really?
Here you get a rational equation because of the minus sign. Photo math, my foot.
It don't always go on there. It is not always this.
Photomath is usually never right. When you put in like the inverse of this logarithmic function, it gives it to you in terms of natural log.
That's a very calculus type thing to do.
Almost too advanced than we are.
And then Delta Math says it's wrong. No.
Can you consolidate the left-hand side using log law number 2?
Isn't it like a division of power or whatever?
So when the base is the same and we're subtracting, we can write it as one logarithm. Now, Franklin has correctly identified this as the natural log, so its base is implied e. I like to go ahead and write that up. This is x minus 1 over x plus 1. And then we should be able to say, can you see it? That's e to the 8. E to the 8 equals that fraction. Now, guys, at this point, if you have been putting in the work, if you've been getting that juicy math pump, so to speak, then that should be doable for you in just a matter of seconds. Right? I didn't use a calculator. I'm saying setting that up. Now, what is e to the 8? What is it? A number. So if this is a rational equation, you guys remember what we said how to solve a rational equation? Multiply both sides by the LCD, or in this case, just the one denominator. So we've got e to the 8th times x. E to the 8 times x plus e to the 8 equals x minus 1. Now that's dog, cat, dog, cat. You got 2 x terms and you got 2 non-x terms. Let's get this dog's on the same side and the cat's on the same side. Freddie, open your eyes. Mitch, pay attention.
How do you get the plus?
Times both sides by the denominator. X plus 1. X plus 1. And then that e to the 8th, which is just a number, gets distributed. Okay. Now, dog, cat. Keep the dogs on one side. Subtract what? Subtract x. So we got e to the 8 x minus x. And then let's subtract e to the 8 equals negative 1 minus e to the 8. At this point, I've got a couple of x terms. What could I do with that x? Ooh, I'm pushing some algebra 1 this morning. Factor out the common factor of x. And you're left with e to the 8 minus 1. Welcome to big boy math. What would you do to both sides? I gave you a hint by putting the times on it. Divide by. No. E to the 8th minus 1. E to the 8th. No, it doesn't cancel out. Well, actually, it does on the left. Sorry. I thought you meant on the right. Now, here's where I get a little bit OCD. I'm not a big fan of all the negatives. I'm going to rewrite this just a smidge bit. I'm going to rewrite this. So here we go. X equals, we're going to go e to the 8 plus 1 over, no, we'll do 1 plus e to the 8. I like that. And 1 minus e to the 8. I like that. So what did I do? I got x by itself, but then I canceled out a -1 on top and a -1 on bottom, and structurally I matched it to where it looks pretty.
Yes, of course.
Right? Did you have to do that? No, because you left your answer just like this? Sure, because that answer is still the same. Number. Okay. But this, did I use a calculator that entire time? I did not. Okay. Blake. Can you see it? Back at the beginning here, start with the base, swoop around to the other side. We got e to the power of 8 equals that fraction.
I got it.
All right, let's see, Stephen, if you can help, because Kenneth has asked an excellent question. Where did that fraction I've got circled in green, where did that fraction come from to begin with?
So you're like the common log, like the base is the same, but fine.
When we're subtracting, the quotient property, log law number 2 says you can take the first argument divided by the second argument, have it written as one back. Now, what did I've zoomed out now to note, what should we do, Christian? I keep picking on Christian about this. I don't know why. Look for extraneous solutions. Now, this is an unwieldy number. This is just kind of, it's an ugly number. Okay, so here's a little, again, some calculator help. And you guys without these calculators, I guess are maybe kind of hurting today. But did you know you could store that as a value? Okay, let's do this. Let's go, we're going to hit second fraction, 1 plus, oops. See, I think my numbers block is messed up. 1 plus e to the 8. 1 minus e to the 8. And instead of typing that in over and over and over again, I'm sick of that. Why don't I just store that? My last name is Morgan, so we'll store it for M as M for Morgan. All right. Now let me ask this. What would make for an extraneous solution? What are you not allowed to take the log of? You're not allowed to take the log of a negative number. And yet, look over here. I've got natural log of x minus 1. So if this number, if I took one more away from this number, what kind of number would it be? It would be negative, and therefore it is an extraneous solution. Okay, it's an extraneous solution. Another way of verifying this, see, look, if I did natural log, where's natural log? Left side, not second. Natural log of m minus 1. Michael Davis, what am I going to get? I'm picking on you again because last time you got this. Error! Dun, dun, dun. No, you still couldn't. Yeah, both of them would be error. Now, there's a backup hack. What? No. There's a backup hack. If I did natural log of x minus 1, we got plenty of time. We're okay. Minus natural log of x plus 1. What should I make y2? Good. Was that Nash? Good, Nash. And then I just hit zoom 6. Does it look like they're going to meet?
No. Probably. Oh, wait, no. That'd be sick. If we add some solid to that, why am I going to do?
Yeah. Interesting.
So, we were never gonna. Let's see what you think.
They're on the quiz, apparently.
Yeah, but like the question that you can't find is me.
The exam is multiple choice, so one of the options might be no solution. By the way, did y'all get my emails?
Steve, yeah, I still need to
Oh,
talk
that
about
one.
it.
What?
There are 35 questions. 30 of them are multiple choice, 5 of them are true, false. We're talking about the exam color. And I gave you recently, I think that's enough, Brady, if y'all need another volume. I gave you recently, I just went through the exam and looked at every question type and said, okay, this is the question on such and such, or that's the question on. So pretty much, you know what's on the exam, and that'll kind of help you slim down your study material. I hope that helps.
Thank you, Foreman. Morgan.
I did. I heard. I approved it.
For everything you know.
Monday's the deadline. I would like things turned in according to their regular due dates. Eli, they are all the same.
Good, Morgan.
All right.
I didn't give.
Yeah, if I'm listening. I got you. I have no idea. I will have a planning period today during 5th. I might get to it then. I'm not sure though. When was the remix due? Yep. So that means no. That means it needs to have been done back then. All right. Mitch, turn around. What have we got on the docket? Listen carefully. We've got homework in Delta Math, 6.1, 6.2, 6.3, 6.4, all of that logarithm stuff. Okay. If you've been staying on top of things, then 6.3 is where you should probably be working right now. If you've been staying on top of things, you've already done 6.1 and 6.2. Okay. 6.3, it looks like not very many folks have made much headway on this. And so what I would like for you to do is I would like for you to get on the stick with this. I've got it set due Friday, and I think that would be wise to start there. Okay. How did it do? I've got what I'm going to have you guys be able to say is by the end of the week, you've got everything done that you need to have done. Monday, Hayden. You done? Yeah, I'll be in here.
We like yellow or green?
Okay, how much time do I have left? Perfect. I have a Kahoot for us to do.
Did you say yes?
I have a Kahoot. The top 3 finishers of which
Wait.
a bonus point.
I got an even better idea than the.
Hey, Coach, why can't I do one of them team?
Can it be the top 2 get bonus points, the top 1 gets a home run?
No. Y'all get your laptops out. Sit behind Mitchell Gilmore.
Oh, no.
I gave my laptop to Nicholas after today. I gave my laptop to
Grab your cell phone. Can you do it on that?
No, wow.
Why not?
I don't hoop on my phone, and I can't get to the internet.
You can't get to the internet. Well, that just stinks for you.
I know.
Why don't I don't want this?
Maybe you want to. Yeah.
I hate that Kahoot is trying to sell me stuff.
Well, they're trying to get you to like get their premium.
Yes.
That's good. They're trying to sell you. You need like the premium version. You can like do better.
Damn it, I gotta go to history.
I could, though, I like.
I did.
Is this yesterday, today?
You can probably put just get Kahoot in the search bar, I bet.
That's today. See, I did it on my television. That's what it was. Ah. It had 10 questions. Maybe this one.
Doggy, loggy, dog. There's a free cup one.
Yep, this is it. All right, host live. It's pretty rapid. Everybody's got all these good suggestions for me. He hasn't put in your grade because you've only done it within the last couple days.
Bro.
Oh, yeah, I'm first. Being first the game.
Oh, they got Chris.
Good luck.
Who's Mario Stinky? Mario Stinky.
That's bullying, coach. You gotta remove that guy.
Cyberbullying.
Look deep.
Look deep.
That's the neighbor. Oh, Kenneth, you gotta log back in?
No, I'm in already.
Really? I don't see your name. I should have made my name MG. Oh.
Ooh, is that a girlfriend joke?
MVP.
No, who's that? I've never known.
Oh, that coach.
MVP.
Oh.
Y'all be nice. We are recording this.
Why are we recording the Kahoot?
Oh.
Why not? We want to put your
Gonna know the answer.
we want to put your fame on YouTube.
Is that you?
All right, let's go.
I'm not done yet. Give me a second.
Here, we'll all wait for Mitch.
Thank you.
Good.
Calculator needed?
You don't need a calculator.
BJ, are you sure?
Yeah, these first few are quite easy.
I'm not a fan. Yes, I'm thinking now.
Well, what about the internet?
Oh.
I
didn't rather be.
Yeah.
This is not the Kahoot that I did yesterday, so this is gonna be interesting.
Can you see it?
Yeah.
Can you see it?
Well, it's gonna go bad. We're just like.
All right. Good job.
Oh, longer rhythmic.
This is where I mess up.
How,
Sorry. Yeah, yeah.
Wait, I got it.
It's